I don't know, I think it's on. Yep, it looks like it's recording. Alright, trying some enhancements to the video function here. So let's see how this goes. It's a little too much echo probably, but who cares? Let's try it anyway. So response video to Holiday. Probably should turn the other light on, right? Let's see how that works. Ooh, light. Let there be light. Let there be light. There it is. Ooh, there is light. Yeah, the focal length is probably wrong, but we'll see how this goes. Anyway, try to keep the paper still. And try to keep my... Ooh, pen hits the camera. That's pretty cool. Anyway, yeah, that really doesn't look right. I think I need more distance between... You know, I probably don't, but... Probably do, but... Probably, maybe, possibly do. I think we'll try a little bit higher, just for convenience sake. Alright, I know. Blank screen and noises and inconsistent volume. Yeah, it's all part of the charm. You'll get used to it. The new Inmendum. Well, draft science guy. Alright, anyway, Holiday. So anyway, he kind of speculates that the universe is maybe not matter. I would argue that, yeah, okay, we can say it's not material, but it's still physical. And I think it's just easier. I mean, maybe it is, you know, so it's so distant from us, these subatomic entities, that, you know, the whole idea of physical doesn't really mean anything, you know, just because we're always dealing with matter, which is, you know, an abstraction of the real fundament. So I don't think it really matters. We just know that these bits are doing something. So I guess that's where you start, is with the bits. You know, there's some sort of thing that the thing's made out of. And I'm going to argue that the geometry is pretty simple. You know, that it's some sort of checkerboard simple, and that something is in a state, and it is compelled by circumstances to change its position by some degree. So it could have some degree this way, it could have more of a degree this way, you know, some bit this way, some bit that way, and that it's the overall pull of what might be called tension strings that'll decide which way it goes. Something like that. I don't even know if you can see that. I should have defined the parameters of the viewable area before going here. Anyway, this is a draft video of a draft science video. So anyway, I'm going to argue that yeah, there is no force, there is no field, there is just bits affecting bits. So we could argue, I think, that gravity, for example, you know, if a body has gravity, that is a stream of bits that changes the arrangement of anything in the field, theoretically. And that, so obviously when you're closer to the center, the density of this flow would be higher than when you're further apart, meaning the particles would be further apart out here and much closer together in here, indicating higher pressure of flow. You know, what that is, you know, whether that's something above cosmic rays or something, it doesn't really matter at this point. You know, I don't have to establish what it's made out of, just that it's the thing changing the matter. And what happens to the matter, it's not that the force doesn't actually push anything. It doesn't apply a force in that sense. What it's actually doing is changing the configuration of the matter, so the matter itself gains a change in arrangement, and that change of arrangement creates the motion. And that's why the motion is perpetual until some other force rearranges it. So in the case of perhaps gravity, you know, going into the gravity changes you, and then going out of the gravity changes you. So you end up with a net where you started, kind of thing. but that explains how you can maintain acceleration, you know, in a gravitational field. You get what you started with when you come out, in terms of you get your whatever arrangements haven't been changed. So I'm going to argue that matter moves because the physics inside of it moves. The matter inside the matter, the atoms, change. And so he asked specific questions, so I guess I'll just answer them in this video. So I'm speculating that this quanta you call photons. Let's say everything's made out of photons, and they're of shorter and longer configuration. I would argue that they're sort of dumbbelled, but it doesn't really matter. What I'm arguing is that an electron is just like the double helix of the DNA molecule, same idea. It's a an arrangement of photons tied together in a spiral, and that the depth of that spiral will indicate the speed of the electron in its linear state, in its moving state, likely in its moving state. I haven't yet established whether these can move linearly or whether they're always in this other arrangement. But anyway, so this accounts for the spin here. And as the spin changes, obviously these photons are all moving at the speed of light, and the spin would take away some of their speed because they're moving this way as well as this way. So their total speed has to be, you have to subtract the two speeds to prevent any of the individual pieces from moving faster than the speed of light. So the argument is that all these individual pieces are all moving at the speed of light. It's just that through rotation they compound their movement and therefore reduce their perceived speed. So the other point being made here is that the electrons in the atoms, so back to movement, create movement because they're in a condition of a loop that goes one photon, one Planck constant, let's say, of overlap in its rotation. So the electrons are basically in a circular, chasing their tail configuration with a potential opening at one end. And that this opening provides a opportunity to explain the how electrons bond to atoms. Once the atom is established, let's say it has its electrons circulate it, other electrons can circle by locking into that electron, and that the idea of how this could end up expanding becomes kind of apparent. That eventually you could have quite a bit of distance created in the atom just by the extension of these loops of connected electrons. And obviously as they get further out, they're capable of holding more electrons in these loops because there's more space. They're not banging into each other, so to speak. So anyway, that movement, I would argue, is in the foundation of movement is in this overlap. So that all movement is a consequence of the arrangement of all the net electrons inside of any piece of matter, and that there's a net force created by the overall configuration of all the electrons, and that if you rearrange the electrons in a particular way, you will change the net movement of the substance in a direction, because you have arranged the electrons so they're spinning in a particular direction. They're on that plane. So obviously this could spin 360 degrees at this angle, and still have a net force of eating space in this direction. So this electron, when spinning, tends to move in this direction. And so it is the tendency of movement in the electrons that's creating a lot of vibration, because some are moving one way, some are moving other ways, and it's the end result is the net configuration, which is the balancing of all these internal forces and vibrations. And so that's what, so acceleration is merely forcing a rearrangement of the matter to go in a, to realign the net balance, so more electrons are eating space in a particular direction. And obviously as you move faster and faster, it gets harder and harder to create these arrangements without starting to degrade the structure of the atoms. And so I would argue that even in a frictionless environment, what will happen to matter as you accelerate it is that it will start to melt, it will start to degrade, create heat, create light, because it will start breaking the bonds of its atomic structure if the atoms are large enough. So that would so the friction with other matter, if you're banging into things, obviously you're creating heat because you're destroying the structure of bonds between molecules, and but when you start destroying the bonds in the molecules themselves, you know, that's what's sort of going to happen as you accelerate matter faster and faster, is that you're basically forcing it all to move the speed of light in the direction of your choice, and you will eventually force it to become back into electrons and be that are linear, and then eventually force those electron bonds to also break and convert the matter back into all energy, which is just photons moving the speed of light. So that's why matter can't move the speed of light, is because the constituent particles are already moving the speed of light. Yeah. So let's see, what else do I need to account for? You know, the phenomenon of the glass, you brought that up. That's if that shows quantum effects. What I'm arguing is happening with the glass example. So here's two thicknesses of glass. My argument is that there's a difference in the face of molecules. A molecule viewed from one direction is going to look different, is going to be configured different than a molecule looked at, an atom looked at from another direction. So in one direction it's going to have a tendency to have more electrons in its face than if it's viewed from another direction, just because of the imbalance of the chemical structure. So what I'm arguing is happening in the case of glass is that when the glass is a specific thickness, all the atoms are connected to each other. Rather, you know, in glass they're bonded rather tightly. It is a solid, even though it's technically a liquid, it is a solid liquid. And what's happening is, as you make the distance, the container for those atoms, when you change the container size, you change the configuration of the atoms. So where an atom was, you know, its two faces could have been this way, you know, the triangle this way, it'll now be a triangle this way, in terms of how the majority of the surface atoms are facing. So that's why when light encounters this surface, it's encountering atoms that have a different face shown to them, because of they arrange themselves based on how thick this container is. So as you change the size of the container, you'll change the rotation of these atoms on their faces, and with each turn of the, you know, as you turn the atom, you'll change whether the electrons are of the, say it's just a simple water molecule, you have the hydrogen, the two oxygens, whether you'll hit an oxygen or whether you'll hit a hydrogen will be changed with probability, which one you're likely to hit. If you come in here as a photon, will change as those molecules had to be rotated to fit the size of this container. So anyway, this is probably enough for a experimental video, and so we'll leave it at that. Trying some different things. Couldn't find the camera that I wanted to use for this. I had a camera just made for it. Couldn't find it. I've got 9,000 cameras and I can't find the one I want. I had it 3 days ago. Had it in my hand. Can't find it. Anyway, I'm going to try to hit the button. I have this camera inside a lamp. I have to figure out a way to hit the button without doing this. This is a little bit too really difficult to get my finger in there. Okay, so till next time, touch.